winter season. We've thankfully gotten a bit of snow, so it finally feels like winter. Just a couple notes. Oh, I just got word that we don't have audio. Oh, there we go. Okay, so j- welcome. It's like I said before someone pointed out that we didn't have audio. We are streaming this live. We are not in person at the observatory right now, as it is winter and the ice and cold do make it slightly hazardous for the public to be up there. A couple notes before we get started. You can check us out at uacnj.org. Uh, there, that's our website. You'll find a list of all our presentations available, a list of our member clubs, and a whole bunch of other resources to help you get started with your astronomy journey. You can also check us out on Facebook, Instagram, Twitter. We have a Discord now, and those are also where we will post pictures if we have any upcoming events, as well as that will be on our website. And last but not least, we are a nonprofit, 501c3 nonprofit. Uh, Everything we do has been supported from generous donations from viewers like you. Not to take from the old PBS slogan, but as such, if you do wish to see us continue, and the best thing you could do is drop a like and follow below on our YouTube. Uh, Hit us up on our Facebook. Friend us there. If you want to support us monetarily with our upkeep and paying our bills, you can also hit us up on our website, and we have links for our Patreon and things like Amazon Smile there. So, with that, we're going to get started with tonight's presentation, which is What's Up in the January Sky with Lonny. He is our returning speaker and has been doing this talk for I forget how many years now. And in case you were wondering, if Lonny Buinis is making up all the fantastic stuff you'll be hearing about tonight, please rest assured that he holds degrees in physics and computer science from Stevens Institute of Technology. So if he does invent something, it'll at least be a little bit convincing. And tonight, what we're going to focus on are three planets, finding the farthest thing the human eye can see, and we're going to get a bit of history and news and look for the bright stars of early winter. And with that, welcome Lonny.
And Chris and many others who make this possible. So do come and visit and talk with the amateur astronomers. They'll be very happy to help you learn all about the sky, which is what we're going to do tonight for January. There's a lot of good references out there. I'm not going to bore you by listing everything, but I found one I hadn't used before, and it's called go-astronomy.com. Go-astronomy. And there you can get a calendar of events that lists stuff that's coming up, which is what I've done here. So memorize this list. There'll be a test later. We've always got a couple of moons every month to be aware of. The new moon is when the moon appears close to the sun in the sky. They're not really close. The sun's 400 times further away and 400 times bigger, so they look about the same angular size in our sky. But the new moon is very important because since it's all the way over there in the daytime sky, it makes viewing at night really great. Good time to view early January. Bad time to view, the worst, the wolf moon. Every full moon has a poetic name. Did you know that? Yep, we'll be naming them all as we go along. This month it's the wolf moon. Look for a planet in early January. Today is January 8th, just past the greatest elongation of Mercury to the east or left of the sun at night. So it's a good time to look for Mercury in the evening sky. We've got a meteor shower, a minor one, and a comet. New comet has visited us and came closest to the sun just a few days ago. This is Comet Leonard, otherwise known as C/2021 A1. Yeah, scientists always come up with really easy to remember names. And we're looking at a simulation of the orbit of the comet, which is backwards from the direction of the other planets of the solar system. Mercury, Venus, very close to Venus, very close to Earth, and Mars. And so the comet came very close to the Earth. It was discovered a year ago, actually. It's a fairly new discovery. And when I say close to the sun, perihelion, that means the closest point, that's 5 times the Earth-Moon distance, 5 AU, astronomical units. That's like the standard yardstick that astronomers use. You and I use a yardstick to measure our pace or draperies. Astronomers have a much bigger one. It's about 93 million miles long, an AU. And they expect this comet, because it's whipped by the sun so close and fast, that it will be ejected from the solar system entirely. Minor meteor shower. Did anybody look for this? A few days ago, they seemed to stream out from a point near the end of the Big Dipper. Ursa Major, the Big Bear, or Big Dipper, looks like this. I tilted the picture to show what the Big Dipper looks like about 8 or 9 o'clock at night from New Jersey, where we are. And that's about where the meteors all stream out from a single point. So when you're looking for meteor showers, you want to use some very sophisticated, sophisticated. Say after me very quickly. Sophisticated, sophisticated, 3 times. Sophisticated equipment. You want to use a lawn chair. That's great in the winter, isn't it? A nice lawn chair, lie down in that nice 14-degree wind and use your eyes, your naked eyes. Or maybe you want to wear a pair of goggles in the winter, because meteors stream out all over the entire sky like, they're all on a parallel track. They're kind of like railroad tracks, meeting in the distance. Never quite really meeting, but seeming to stream out in all directions. This radiant point is named is the origin of the name of the meteor shower. That's the same for all meteor showers. Like the big one that I did talk about for what's up in December, the Geminids from, you guessed it, Gemini, right? So it's named from the constellation it seems to come from. This meteor shower is named for an obsolete constellation, the Quadrant, right? So we don't talk about the Quadrant anymore. In 1930, the International Astronomical Union, yes, I'm going to throw a lot of acronyms at you today, the IAU, named 88 officially recognized constellations. Here's a little tidbit. This, the Big Dipper, is not a constellation. What? Yep, I'm not lying. I do make stuff up, but that's actually true. This is not one of the 88 constellations. We'll see why later. So this was the breakup of a minor planet, or maybe a comet, not sure. Astronomers aren't sure, that is. They don't know everything. Yes, gasp. Scientists don't know everything. They're human beings. They make mistakes just like you and me. And I'm not a professional astronomer. I'm an amateur astronomer, so I make lots of mistakes, but I cover them really well. We're going to look for a planet before it disappears. The one closest to the sun means that it's hard to find because it'll always be near the sun, which means you've got to look very close after sunset to find the planet. Yep, you guessed it. It's labeled right there, Mercury. This is a simulated view in a free computer program called Stellarium. a program that I'll be using in a few minutes to simulate the sky in real time. Notice we're followed by Mercury along a red line. You always see this, right, when you go out? You see the ecliptic. I'm making this up now. Can you tell? You cannot see the orbit of the Earth projected out into space, but you can draw it in stellarium. And the planets, the moon, and the sun all follow this because the solar system is, to use the technical term, flat, pretty much, except for Mercury a little bit, Pluto a lot, comets, oh yeah, quite a bit. But the major planets all can be found going through the signs of the zodiac in a flat plane. Saturn, Jupiter, two bright planets are now disappearing in the early evening sky. So look for these planets making a nice line. Early January, notice I said January 7th, that was yesterday. The moon made a nice grouping yesterday with these planets. Anybody see it? Or did you see snow? Yeah, weather is always a problem. We have to work around the weather. A little bit of history on this day, 1961, not in this month, on January 31st, the first primate made it into space. Not orbit, just up and down into space. And other tidbits, Japanese space probe was launched to Halley's Comet. Famous comet, it's about 6 miles across. It's a fairly good-sized comet. It's not the biggest. The biggest comets are about 100 kilometers or 60 miles in diameter. There have been several great, so-called great comets that size. Halley's puts on a nice display, though, every 76 years. I saw it in 1984 and 1985, and the Japanese space probe Sakigake flew by millions of miles away from the comet on January 7th. Let's take a look at what the sky looks like by, well, you can download this program, works on a lot of different operating systems. Stellarium. Notice on the upper left something peculiar. I started with this program. When this program began, it was 0.7. I caught up to it about 0.12 or 13, somewhere around there. It's now up to 0.21. When? It's been years. When are they going to get to 1? I don't know. But the nice thing is it's free. It's open source. Any programmer can contribute to it. Some of you in the audience, some of you young people, if you grow up to do some coding, maybe you can contribute to Stellarium. Please get it to number 1, would you? For me, for yourself. Stellarium-web.org is a website that runs it using their computers. You don't have to download anything. Or if you want to try it on a mobile device, Stellarium Mobile is free. Stellarium is free. And I'm going to use it right now. To simulate the sky. Here's the sky with a lot of light pollution. So kind of like where I live. I can find the Big Dipper at 1, 2, 3, 4, 5, 6. Can you all see my arrow? My cursor arrow? All right, if anybody can't see what I'm talking about, please alert Kim and our helpful tech team, and they will stop me in my tracks and I'll backtrack. So we're facing, what direction is it in? Take a wild guess. North, northeast, northwest, right? So you would look in the north for the Big Dipper, which, as I mentioned before, is not a constellation. Its famous pointer stars, Doobie and Merak, point about 5 times their distance apart. 1, 2, 3, 4, 5. To Polaris, named for the place where the Earth's North Pole points to in the sky. If you were to stand at the North Pole and look straight up, you'd be pointing just to the side of that star, right about there. From where I live, I see 3 bright stars in the Little Dipper, these. All right, but if you go to Jenny Jump, where the United Astronomy Clubs of New Jersey is based in Hope, New Jersey, not far from the land of make-believe, we can reduce the light pollution to see what it looks like there. And I'll just leave a little bit up. Wow, that's confusing, isn't it? but you get some great viewing at UACNIJ, or the United Astronomy Clubs of New Jersey. I'll just say UACNIJ for short. You can also do things with Stellarium that make it work like a star chart. You can zoom out, so you see it like a planisphere, a circular star chart. Not very useful. You can, as we say, using the technical term, you can do things like this too. Technical term, cheat. All right, leave up lines that give us a little better opportunity to imagine what these things might look like from their names. The Great Bear, Ursa Major, is the constellation. The Big Dipper is an asterism, a star pattern that can be a piece of a constellation or something all its own. Occasionally we see a meteor. This is exaggerated. You're not going to see that many. But we can see all of the Little Dipper, which has 7 stars, just as does the Big Dipper, one of them hiding behind a house. Little tidbit of information. The Big Dipper, actually, you can see 7 stars with the unaided eye, but if you have pretty sharp eyesight, you might see an extra one in the bend of the handle. This is an apparent double star, Alcar and Mizar. Alcar, 82 light years away, Mizar, 78. So they're not close to each other. Let me tell you, several light years is a large distance. 1 light year is about 6 trillion, that's 6 followed by 12 zeros, miles. 6 trillion. Hard to imagine. That's why astronomers use astronomical units in light years, because miles, millions, billions, trillions, after a while, it doesn't make any sense. You like the way I can zoom in and out? Constellations in the real sky look, as we say, to use the technical term, as did Douglas Adams in his book, Hitchhiker's Guide to the Galaxy, really, really big. Yes, space is really big, and so are constellations. Draco, what's Draco? Can you imagine? Dragon, Draco, or Draco, say it how you like, lies right between the Big and Little Dippers, and about 3 to 5, 5,000 years ago, that was our pole star. That's where the Earth's North Pole pointed, to Thuban, Alpha Draconis, Alpha DRA. For those of you who like abbreviations, astronomers abbreviate the constellations with 3 letters. So Ursa Major is Ume, and Ursa Minor is Umi, and a famous actress is Uma Thurman, but she is not in the sky. So our pole wandered from here to here over several thousand years, and it's going to wander again. It's just wobbles like a top. The whole Earth wobbles, yeah, very slowly, about 25,000 years. And so eventually the bright summer star Vega, or Vega, will be our pole star. You notice that when I click on an object in Stellarium, it identifies it, gives you a little bit of data. You can have it give you a lot of data. You can have it give you massive amounts of data. You can have it give you no data. I've turned it to a moderate amount. In the north, I like to get started here because these constellations, the House, actually Cepheus the King, Small Bear, Big Bear, Dragon, and the Queen, Cassiopeia, are always up. They never rise and they never set. They just circle around, a big circle around the North Pole star. In the southern hemisphere, there are also southern circumpolar constellations that we never see from New Jersey. They circle endlessly around nothing because the people in the southern hemisphere aren't as blessed as we. They don't have a bright star near the South Pole. They have a cross that points to the approximate position. So we can feel superior here in New Jersey to the poor people in Australia. In the winter, the swan, Cygnus lies on the horizon, used to be called the Christmas cross or evening cross. Am I making things too easy with the ecliptic? We can make it go away. We can make a lot of things go away. We can make things really confusing. If we look over in the west, we'll see some of the main signs of fall disappearing. A huge square in the sky. I mean, really, it's really big. When you look at it with the eye, to look from the head to the wings of the flying horse Pegasus, you've got to move your head like that. Anybody dizzy yet? Nobody nauseous? Sorry. I'm looking out there to see who's turning green, and I'm sorry, I can't see you. And due to slight technical difficulties, you can't see me live. But we'll see if we can solve that for next time when we tell you, you guessed it, what's up in the, yep, February sky. Let's see if we can get our video working. Pegasus, flying horse, is disappearing in the west, as is the most distant thing that you can see in the entire universe. And here, it looks like a fuzzy blob. See that? If you go to the top of the Great Square of Pegasus, that's what we call it, we amateur astronomers, the Great Square. It's big, it's great, it's a square. Count 1, 2 stars up and 2 stars over. And in binoculars, it's kind of hard to see by eye, but there's a kind of a little Y-shaped group of stars here. Right in the spokes of the Y is something that is so far from us that we're seeing it as it was 2.5 million years ago. It is 2.5 million light years away. A light year is not a unit of time, as was used in an old Star Trek episode. It's a unit of distance. It's how far light travels in 1 year. About 6 trillion miles, very, very roughly speaking. In a pair of binoculars, you can sense a little bit of structure in the Andromeda galaxy. It's a galaxy like our Milky Way galaxy, which we now know has about 1 trillion stars in it. Yep, again, that's 1 followed by 12 zeros. That's 1,000 billion. That's a million. Now, what's this? Something's moving. I clicked on it and it says it's a global star satellite, an artificial moon of the Earth. We have hundreds of thousands of these things orbiting us, and sometimes you can see them, sometimes they disappear into Earth's shadow, right? Sometimes they annoy astronomers, especially the new Starlink satellites by the tens of thousands. There's going to be more and more of them. They can get in the way of fainter objects like the Andromeda galaxy, which we call a deep sky object. In a small telescope, you can start to see some structure. And in a very large telescope, we see dust, dark dust, hiding the light, diffuse light of starlight, reflecting off of gas. Galaxies are big collections of gas and dust that coalesce into stars. Old stars reddish in color, new stars bluish in color. Beautiful. Can human eyes see colors like this? Nope. Human eyes not very good seeing colors at low light levels. We can see a couple of satellite galaxies orbiting Andromeda, just as the Milky Way has the clouds of Magellan, the Magellanic Clouds, seen unfortunately only from the southern hemisphere, not from New Jersey, not from the northern hemisphere. There are many satellite galaxies going around the Milky Way and going around Andromeda. The whole of the local group of galaxies includes the 2 big ones in our local group, Andromeda, a little bigger than us, and us. And the 2 galaxies will merge in about 5 billion years. So in case you're panicked, have no fear, it's going to take quite a while. And it will be more like a merger than a collision, because the distances between stars in a galaxy are huge. So if you want to find that, look for the Great Square setting in the west. I'm going to move over to the south, though, because here we've got some of the most interesting things in the sky, the planets that follow the ecliptic, which I am going to turn off, because you're going to see that in the real sky? No. You can make the sky as realistic or as unrealistic as you want in Stellarium. Even if you don't have lines to help you in the sky, you might recognize some of the brightest stars of winter, the early winter sky. This distinctive grouping that looks more to me like this size, Orion, the hunter. Almost looks like that if you use your imagination. There's a little feather or crown on his head, a helmet maybe. The upper stars could be arms, feet, knees. The knee star, Rigel, bright blue. The belt, holding a hanging sword. One of my favorite stars, Betelgeuse, Alpha Orionis, Alpha ORI, reddish in color. It's not the shoulder of the giant. The literal translation, Arabic, is the armpit of the giant, the armpit of Orion. Yep, there he is, holding a wolverine, not Hugh Jackman from the movies. Orion the hunter. Even in a pair of binoculars, even small binoculars, you can sense a fuzzy cloud hanging in the middle of the sword. This is a great gas cloud. We use the scientific term nebula, a place where stars are forming. Gas and dust also coalesces to form stars, as I mentioned earlier, in galaxies. It does it in nebulae, plural for nebula, in our own galaxy. Some of these stars about 1,500 light years away, 1,500. The distances become mind-boggling after a while. Really helps to make scale models. Beautiful collection of gas glowing in the red light of hydrogen, reflecting blue light from the young stars that are just formed. These stars burn through their fuel so quickly that they're gone before you know it. Our sun's going to be around for 5,000 million years more, 5 billion years. These stars will disappear within a few hundred million. Very young stars burning up their fuel very quickly. There are all kinds of stars. There are tiny red dwarf stars that last for trillions of years, thousands of billions. The sun, only 5 more. Running out of time. So that's the hunter, Orion, who helps us find other famous stars of the winter sky. The winter triangle, I mentioned the summer triangle when I talked about what's up in summer, what's up in July and August, September. In winter, you're going to see very bright stars, Rigel, Betelgeuse, Sirius, only a little over 8 light years away, and the little dog star, Procyon. Pro coming before Scion, the dog. Sirius, dog star. This is the big dog. This is the little dog. Big dog kind of looks like a dog, doesn't it? Head, tail. Little dog looks just like a dog, right? Right? I hear dissension from the audience. I have a good imagination. We've also got something with a horn, looks like a horse. Mono, one. Ceros, horn. What does rhino mean when you have a cold? You have a rhino virus, a nose virus. A rhinoceros is an animal with a horn nose, a rhinoceros. So we've got the unicorn, monoceros. Monoceros, if you know where to look, let's turn off the picture. There's some very nice object in it, a deep sky object. One of my favorites, that is a nebula glowing in the red light of hydrogen. Looks to me, others, a little bit like a rose. So it's called what kind of nebula, or what fanciful name? Yeah, Rosette. Rosette Nebula. These objects are beautiful. They're fun objects to try to find with a telescope. So you can come to the UICNJ observatories. We have a collection of several observatories. And there, the astronomers will be very happy to either let you look through the telescope when it's safe to do so once again, maybe when the COVID virus has diminished. We also project images on the side of one of the observatories so everybody can see it at once without looking through the eyepiece. But it is kind of fun to look through a telescope, so we'll be doing that again, I know, in the future. Monoceros, location of the Rosette Nebula. A lot of fun to try to find these objects. Famous sign of the zodiac, two people who look alike lying side by side. The origin of the Geminid meteor shower. Gemini, you guessed it, the twins. And in the sky, the human eye, even though the human eye is not great at seeing color at low light levels, stars are, as we say using the scientific term, bright, right? They pack a lot of light in a small area. So you can see that Beta Gemini, Pollux, has a yellowish color. And in the real sky, Castor Alpha Gemini has a bluish color. So what would our sun look like from far away in space? It would look a little like Pollux, kind of a yellowish color. And in fact, if you were to visit the nearest star to the sun and look at this constellation in the north, I'm going slowly so I don't make everybody dizzy. All right, anybody feeling nauseous? Sorry, I'll slow down. Look for the big upside down W or the letter M in the winter sky. And you would find a zigzag of stars. You would see a bright yellow star about here from Alpha Centauri. And that bright yellow star would be one of the brightest stars in the sky, and that would be our sun. We've covered a lot of ground. I don't want to confuse everybody, so I'm going to end by looking higher in the sky, starting with Orion. Orion's a great guidepost. You can find his belt and follow it in a line down towards the dog, the big dog, Canis Major, dog big. Canis Minor, you guessed it, dog little. But you can also go up in a line past the Hyades star cluster with the bright eye of Aldebaran, the eye of Taurus, sign of the zodiac, yes, the bull, Taurus the bull. Long horns, the face, the eye of the bull. The eye is a reddish giant star, red giant star, 66.6 light years away. Betelgeuse, reddish in color, was recently dim. If some of you have been observing Betelgeuse over the past couple of years, it dimmed. Either a large amount of debris passed in front of it in a disk, or the star, which is unstable, did something weird on its own. But it seems to be coming back now. It's getting brighter. It's the first time in my life that I've seen Betelgeuse dim. Aldebaran, another red giant star. Even closer to us than this old group of stars, the Hyades, on the order of 150 light years away, 170, 160, they're close together. Aldebaran is in front at 66. So you see, a lot of these alignments are accidental. If you went out into space, the constellations would look different. If you look closely past Orion's belt, past the face of the bull, you'll see something that looks like a little dipper. And many people mistake this to be a little dipper. This is the Seven Sisters, the Pleiades star cluster. Pleiades star cluster. Beautiful, they are young stars just born recently. Look, there's the gas they were born from. Glowing blue because the stars are young. Hot stars glowing bluer than the sun's yellow color. Think about a gas flame, if any of you still have gas heat. I read recently that the governor of New York State is doing away with gas and natural gas and oil sources in new buildings. She wants everything to be electricity. Where do we get electricity from? Does that cost money? Yes. Right. So is this an economical move? I don't know. But I generally don't discuss politics when we talk about the sky. So blue, you look at a gas flame, blue is near the bottom, orange, yellow toward the top is cooler as the heat moves away, right? So blue is hot, star is hotter than the sun. There's some interesting stars here. Pleione is a fast rotating star, so fast that it's squashed out like an egg, or more like an oval track. It looks a lot like the planet Saturn, when Saturn is edge on to us, when the rings disappear, half of the 29-year orbit of Saturn around the sun. The rings seem to disappear. Right now, the rings are open. But Saturn looks like a squashed egg, so does Pleione. It rotates so quick. Look for the Seven Sisters. You might see 8, 7, 6, depending on how sharp your eyesight is. 2 star clusters in the winter sky. There's lots of stuff to see in the area of Orion. Lots of nebulosities, dim ones, brighter ones. This whole complex near the Great Nebula of Orion. There's more here. There's a famous dark nebula, gas in front of hydrogen. Dust in front of the hydrogen gas. Looks like a famous animal. This is what? What nebula is this? Horsehead. Do you see how it's drifting compared to my arrow? That's because the Earth is rotating on its axis. If you have a telescope that stands still and doesn't have a clock to move it, to follow this movement as the Earth rotates, things will move out of the field of view. An astronomical telescope is a very small field of view, so things move out very quickly. There's even ghostly nebulas, dark ones. All sorts of interesting objects to see in the sky. I'm certainly no expert, but we have amateur astronomers at UACNJ who've been doing this for decades, so they will be very happy to show you the sky through their telescopes, as long as you don't kick the mount that the telescope is on. Otherwise, you will see a very rare event, an astronomer crying. In the winter, you don't want to cry. It's just too cold for tears. If you look towards the eastern sky, you'll see the stars of late winter and early spring coming up. And we'll be talking about those more in the future. We've got another sign of the zodiac here. Looks just like a crab, yes? No? Don't take my word for it. Cancer the crab. Well, you see, our ancestors had some things that a lot of us are losing. Good imaginations, because they didn't have iPads and tablets and phablets and smartphones, but they had good imaginations. I see a lot of lack of that. You'll see Mark Twain used to talk about the Congress in that way, a singular lack of imagination. But they also had much clearer skies, the kind of skies you see at UACNJ. So we'll do a review later. I wonder, should I interrupt myself for questions here, or should we save them? Look, fishes. Looks just like fishes, right? I see a lot of you shaking your heads in disbelief that, how could this guy make this stuff up? Well, it wasn't me. I did not make this stuff up. There's a sea serpent who tried to eat Andromeda because her mother, Cassiopeia, boasted that Andromeda was more beautiful than any of the ancient Greek goddesses. Boy, is that a mistake. If you read your Greek mythology, the Greek goddesses were among the most jealous of feminine creatures ever to have existed. So along came Perseus, the hero, holding the head of the Medusa with the snakes to defeat the Cetus, the monster, by showing it the Gorgon, so the monster turned to stone. This story has not only been written there thousands of years ago, but it became two versions in the movies, 2 movie versions. So if you miss the story, you can see it in the sky, you can read about it, you can see movies about it. The sky is a really cool place. It broadens our horizons. A lot of us may think, what good is any of this? Really, it doesn't have any practical use. Well, it makes us think a little bit more than just about ourselves, about our place in the universe. And that even though we're small, we can make ourselves important by trying to understand how the universe works. If you can understand how, you can get to why. Tonight, I'm going to wrap up things with one of the brightest objects in the sky, our moon. You can see in Stellarium, when we compress things look pretty small. The moon, to our eye, looks big enough for us to see some details, some dark spots. No craters, you really need a telescope for that. But one of the best times to see details on the moon is when there's a sharp shadow going down towards the middle. We're getting towards first quarter phase of the moon. Tomorrow night should be first quarter. That's when you can see details like craters. And that's what Galileo saw in his first crude telescopes 400 years ago. And 10. This little C right here, little, is about twice the length of the state of New Jersey. Mare Crisium, one of the dark lava plains made by a big impact billions of years ago. The moon, everybody's favorite. We're going to wrap things up with some references. This is really easy to remember. If you're curious about space, you want to get events, news, tech, space flight, science, astronomy, the search for life, or just how to, buy a telescope or look for stuff in the sky. Space.com, I think, is the easiest to remember. Space.com. Sky and Telescope and Astronomy magazines are still in print after many decades. They're available online. .com for each, Sky and Telescopes, Astronomy. They're written for lay people like you and me, right? They're not for scientists, but they are very carefully written by scientists, by amateur astronomers, by science writers, by journalists. Really good. And most of their sites are free. You can pay for a subscription, for an online subscription, to get much more. I mentioned the free program Stellarium, which we saw me use before. Celestia is another one, celestia.space. You can download it, you can look at it online, you can use it on mobile, all free. I like free. Do you like free? And this lets you fly out into space. Celestia, you could watch an eclipse of the sun by the Earth if you were standing on the moon. You can go to one of the moons of Saturn, the only moon of Saturn that lets you see the rings open. A good place to build a hotel where the gravity is practically nothing. And the whole moon is shaped like a giant walnut, has a big ridge around the equator. It's called Iapetus. And Arthur C. Clarke in the 1950s said that that would be a great place to build a hotel because in addition to being a place where you can see the rings open from Iapetus, there's only one other place you can do that in the solar system. That is, anyone? Anyone? Bueller. Earth. Comet Leonard looks like this in typical exposures. New comet around Christmas time, discovered a year ago. Here's long exposure showing some dust glowing orange and ion tail glowing blue from the light from ionized atoms. We cannot see the actual comet, the nucleus, the body that's off-gassing direct from solid to gas as the sun heats it. It's too small at this distance. This was an exposure made just recently. Yeah, I know for some of you it feels like a long time ago, like my blathering on and on. I know I started hours ago. I'm going to wrap things up soon. Ion tail with kinks and multiple rays. Who knew that science used such technical terms as kinks and multiple rays? And here's an actual star-like point as jets blast off the nucleus. It looks like the nucleus, but we can't see it. It's still too small. Jets of gas coming off of the comet as it kind of melts. Actually, astronomers call it sublime. It sublimes directly from solid to gas. And you can find all these images that I took from skyandtelescope.org. Fascinating. And now, oh no, a review. Yeah, I'm not letting you get away without a review of the night sky. Back to Stellarium. So, what's a good thing to do? Start over in the north, learn the circumpolar stars. Let's bring up a little bit more, a little bit more light pollution. So we have I keep doing the wrong thing. Marking, oh yeah, of course I was in the right spot, just here. A little more light pollution. Things are not quite so nice. I can still see the Milky Way, wow. That's something you can see at Jenny Jump, at UACNJ observatories, at a place called Jenny Jump. because it is so typically dark in the middle of a state forest. Let's keep it that way, prevent light pollution. How has the sky changed in the time since I started talking? Look, I see 7 stars in the Big Dipper now. This one was behind the building before. Why? The Earth is rotating. The stars seem to come up in the east and go down in the west. So you learn the circumpolar stars, Big Little Dipper, King, Queen, Dragon. Look for Pegasus disappearing. See if you can find the Andromeda Galaxy. The moon is interfering tonight. Also bad weather. But the point is, go out any night. Use your eyes. If you have binoculars, that's fine. That's a good way to start. It's economical. You can use them for other things like bird watching if you get tired of astronomy. It's great. Or small telescopes have come down in price over the years. Look for the bright stars of winter, winter triangle. Betelgeuse, say it with me. Betelgeuse, 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 Betelgeuse. It's got about 8 pronunciations. Rigel, the blue star. Brightest star in the night sky. Sirius. What's brighter than Sirius and closer to us? This is a trick question. Sorry, you're out of time. It's the sun. Procyon, winter triangle, just like the summer triangle. And I happened to hit a Starlink, but boy, you know, you hit anything in the sky and you're going to come across a Starlink satellite sooner or later. Thank you, Elon Musk, for littering the sky. They are painting them black, in case you were wondering if that would interfere with observing. Gemini, the twins. Right, there's lots to see. I hope you're going to come back for what's up in the, you guessed it, February sky. And you can do this yourself. Kids, do this at home. Every view. New moon just passed. The moon is getting more and more fuller and fuller. It's a thick crescent now. It'll be first quarter. The fuller the moon, the less chance of a nice clear sky. The moon's light interferes, but you can still see quite a bit from UACNJ. The comet, still visible. Quadrantid's meteor shower, that's pretty much over. It was very narrow in time, just over the course of a few hours. You can still look for Mercury if the sky ever clears. Thank you, Mother Nature. And the worst time to observe faint objects, but not bright stars and planets, is the middle of the month, when the moon, the full moon or wolf moon, comes out. I'll be listing all the events for each month over the next few months. So I hope you'll join us. Got some more references. UACNJ.org is United Astronomy Clubs, UAC of New Jersey, NJ. UACNJ. Magazines, programs, there's so many I can't list them. I found dozens of astronomy apps. Many of them, the one I use, Skyview. You hold your phone up, the GPS system in your phone will localize. It'll actually key on that part of the sky and show you what's up. Even in the daytime, it'll show you what stars are in that part of the sky. And it will label them and identify them. Don't forget, though, that Stellarium and Celestia are free as mobile versions and online versions and downloadable versions for your laptop. Or does anyone still use desktops? I will be. Does anyone still know what a desktop is? Does anyone know what a pencil and paper is, or a floppy disk? But I digress. This is something we will show you when you come to visit Jenny Jump. We have a gift shop. We have a place to make donations because, as Kim mentioned, we do run on volunteers. And we've done that for, well, over about 27 years now. When I was there when we got started, I hope to be there a lot longer. And I hope that you will visit us again online and in person. And here's how you can reach me. I'm a member of an organization of astronomical artists. There are only 200 of us in the world. You can go to my website and see my work, not only still art, but stuff that moves and stuff that you work, virtual reality, with your fingers, as in my book, Space History Mystery Solved. I'm at astronomyinmotion.com. And I want to thank you all for being a very patient audience. And next time, I hope you can see me live. Thank you, Kim, Jeff, and Chris, for all your help. And thank you, audience. And we'll break for questions.
All right. Thank you, Lonnie, once again for a wonderful presentation. So, we do have a couple of questions in chat, so let's get jump right into them. First question was, would the Rosette Nebula be up in February on
Right, and we could just type things in, like, if I could spell right, Rosette Nebula. You can search, pick it, it finds it for you, it locks on, and then we can change the time and date like this, February 15. Notice how the moon races across the sky? So what time would be good? Well, a lot of us we're still around at 9 o'clock. Younger members of the audience, I'm going to set this to 8 o'clock, right? It's still dark at 8 o'clock in the winter. And if I look where I'm looking in the south, southeast, south and east. And I can click the space bar to center on the object once I pick it and zoom in to get a nice view. Wow. MON is Monoceros. So a star in the nebula is called 19 Monoceros. That's a great question. Something that we can do, fun to do in Stellarium, is move the sky around rather than be in the real sky and have to move our heads around.
Yeah, and since you chose 9 o'clock, usually most of the restaurants close down around 9 o'clock, I believe. So it's a good time to get out after you've had your Valentine's dinner and
Hey,
go stargazing.
did you notice what I did there? 15th. Now watch what happens to the sky. Orion just jumped 30 degrees, as did the entire sky. This is why all of us do a program for you, our beloved audience, every month, because the sky changes. We're looking in a different direction all throughout the year as the Earth revolves around the sun over the course of a year. You're going to be looking 30 degrees different the same time each night.
All right. So the next question we got. Since there are stars that spin so fast they squash into an oval shape, would it be possible to end up to have a star spinning so fast that it ends up becoming a flat disk or a donut?
Oh, that's fascinating. The problem with that is there's the centripetal acceleration, the scientific term we call centrifugal force, would actually tear a star apart at some point. And so the material that formed the star, we now know that disks that form stars spin, right? So everything in the universe pretty much spins or turns. And there has to be a moderate limit to that so that the material can coalesce. Otherwise, it will never form. And so we don't find stars of that type shape, although we might find a planet holding together that's more like a disk than a sphere. And in fact, the author Hal Clement once wrote about a mission to a planet that spun so fast that it had 3 Earth gravities at the equator and many more near the poles. So Earth people who visited had to use the kinds of machines that we have nowadays that help workers lift factory objects that weigh tons. Those skeletons, exoskeletons, they hear those. They traveled to the planet and they met living, intelligent creatures who were flat. And when one of the Earth people lifted up the creature, it was terrified to be lifted even just a few inches, because a fall under that gravity would be lethal. The name of the science fiction novel was A Mission of Gravity. A Mission of Gravity by Hal Clement, famous science fiction author. Check it out. So the answer, basically, my long-winded answer there, you probably would not have a star that would be a disk, but you can have them spin spin enough to be oblong, and then a disk of gas can form around them.
All right. So, um, someone added on to that question. Uh, Is it possible for things to spin out of orbit?
Uh, to leave the orbit of the
So
sun.
basically, gather so much momentum onto itself, spin so fast that it just wanders off, I'm guessing.
Well, no, by the laws of celestial mechanics, you have to have, energy in, energy out. Momentum is conserved. So we have comets coming into the solar system that get captured by the sun, but they have a long time to do it, like Halley's Comet, 76 years. We have discovered recently comets that are one time. They're moving so quickly that they come in on something called a hyperbolic orbit. They'll never to return again. They're moving too quickly. We can escape from Earth's gravity by using thrust in rockets. You have to go faster than 5 miles a second to leave the orbit of the Earth. But that takes energy. So nothing will do it on its own. You have to add energy for things to leave an orbit. Now, how do we reach the planet Mars? We use thrust to send us in that direction. Then we turn off the thrust to conserve fuel and wait to drift to Mars over 500 days. That's called a Hamann orbit. Much more efficient would be to use thrust continuously to accelerate to a planet, but we don't have that kind of technology just yet. We could use ion drive or solar sails that have continuous thrust. Solar sailing being the most efficient, very tiny thrust, but it goes on forever. Boy, that was a technical answer. You have to
Uh,
stop me please stop me if I go on too long.
all right. So I just put out a last call for questions in the chats. While I'm waiting a couple minutes for anyone to get in their last minute questions, I did I didn't notice. I don't think you had anything about the James Webb Telescope finally launching.
Oh, yeah, I'm sorry I forgot to mention that. I should have had some pictures. It's taking a long journey to a point almost a million miles away, 900 something thousand miles away, to co-orbit with the Earth in a place called L2, Lagrange 2. There are these stable gravitational points in the tug of war by gravity between the sun, Earth, and moon and other objects in the solar system. Mostly sun and Earth have the most influence. So there are several points, L1, L2, L3, L4, L5, L2 being about a million miles away. Now, why do we do that? Because the Earth interferes with radio interference, light. You want to get away from all that. And so it takes a while to get there, but it's on the way. And then there'll be months of testing because this thing has to work flawlessly the first time. There is no chance of a rescue mission the way we did with the Hubble Space Telescope in low Earth orbit, only 200 miles up. This is a million miles. It's got to work right the first time. It has to unfold like the petals of a flower because it had to fit into a tiny rocket. And these are big. This is a much bigger mirror than the Hubble, coated with gold, so we can see in the infrared heat rays, so it could look through the dust and gas of our Milky Way to look back right to the beginning of the time when light first broke through our universe, when the universe was 380,000 years old. 380,000, not millions or billions. Amazing. It's an amazing piece of equipment. And I'm looking forward to finally seeing it, the first tests a few months from now.
D- do you, by any chance, recall the date that it was supposed to finally get into position and we should start getting that information back?
I think that's sometime in February. I could be wrong. I apologize for not doing the research.
I just figured I'd ask if you knew offhand because I knew originally I believe it was scheduled for to launch on December 18th and it was delayed a bit
Oh, that's
there.
right. That's right. Originally, yeah, and then it was they were supposed to launch. Oh, yeah, that was something else. January 31st was the original launch for the Starship, a commercial spacecraft, but that's been delayed to February. So never mind what I said uh, about the James Webb. I don't know.
Yeah, unfortunately, Weather and technical difficulties abound even in the professional environments.
Yeah. Yep.
Well, it looks like our questions are done for tonight. I want to thank Ilani again. Once again, it's a great talk. We will see you again come next month when we do What's Up in the February Sky. I do, once again, for all you viewers at home, if you like what you see, hit that like and follow button, subscribe. If you like us even more than that, you can go onto our website and at uacnj.org. That's United Astronomy Clubs of New Jersey. And that will take you to information on our organization as well as links where you can donate. Because, as Lonnie said, we are a volunteer run organization and our upkeep and expenses are all actually paid through donations from viewers like you guys and through our members donating their time and talents. Um, you can check us out on Facebook, Instagram, Twitter. We have our Discord channel, so there is a link there also. And I want to thank everyone who has come tonight, and I hope to see you again next month. And I hope weather clears up
Yeah.
wonderfully for our first presentation on site again in April. All right. Have a good night, guys.
Thank you to Kim and Chris and Jeff to make for making